Hello everyone. Today we are discuss about design methodologies. Design methodologies. An effective design methodology should be defined in terms of design objectives and design choice to be applied at each consecutive design step. Embedded system design can be divided into four major tasks. First one, partitioning. Partitioning the function to be implemented into smaller interacting pieces. Allocating those partitions to microprocessor or other hardware units where the function may be implemented directly in hardware or in software running on a microprocessor. Third point, scheduling. Scheduling the times at which function are executed, which is important when several function partitions share one hardware unit. Fourth one, mapping. Mapping a generic functional description into an implementation on a particular set of components. Some challenges in the design of embedded systems. First one, increasing application complexity even in standard and large volume products. Increasing target system complexity, numerous constraints and design objectives. Example, cost, power consumption, timing constraints, dependability. Reduced and overlapping design cycles. Design flow of embedded system begins with the design specification, its defined system constraint, both cost and processing time. System functionality is defined in behavioral description. Hardware software partitioning is done to optimize design result and still fit the requirement. Design flow. Design flow is a sequence of steps to be followed during a design. Some of the steps can be performed by tools and other steps can be performed by hand. Here, first one is the waterfall model, a requirement, then the next one architecture, coding, testing and maintenance. It is a reverse process. In a waterfall model, each phase must be completed before the next phase can begin, and there is no overlapping in the phases. The outcome of one phase acts as the input for the next phase sequentially. Requirements defines needed information, functions, behavior, performance and interfaces. Architecture, data structure, software architecture, interface representation, algorithmic details. Implementation, source code database, user documentation, testings. Testing, all the units developed in the implementation phase are integrated into a system after testing of each unit. Post integration, the entire system is tested for any fault and failures. Maintenance, there are some issues which come up in the client environment. To fix those issues, patches are released. Also, to enhance the product, some better version are released. Maintenance is done to deliver these changes in the customer environment. Advantages of waterfall model: simple and easy to understand and use, provides structure to inexperienced staff, milestones are well understood, sets requirements stability, good for management control, works well when quality is more important than cost or schedule. Disadvantages of waterfall model: poor model for long and ongoing projects, high amount of risk and uncertainty. It is difficult to measure progress within stage, cannot accommodate changing requirements. Spiral model of software design. Spiral model uses a cyclic approach to incrementally develop the software product while decreasing its degree of risk. It is a software spiral model. System feasibility, specification, prototype and initial system enhanced system. It's a life cycle of system. This model uses planning, risk analysis, engineering and evaluation phases. A software project repeatedly passes through these phases in cycles. In spiral model, before each cycle to involve stakeholders to decide on scope of cycle to arrive at plan. Following this, risk analysis is created out to arrive at list of risk stakeholder, perform concurrent engineering to address these risks through prototyping and before the completion of current cycle. Software is produced in the engineering phase and tested at the end of the phase. The evaluation phase allows the customer to evaluate the output of the project before the project continues to the next spiral. Spiral modes are found very effective for large and mission critical projects. It is a successive refinement design methodology. Here is the first initial system and refined system 1. Here specify and architect, design, build and test. It is going to the next refined system 1. Specify, architect, design, build, test and refined system 2. When developers are unfamiliar with the application domain of the building the system, this model is used. Refining the system by building several increasingly complex systems allow you to test out architecture and design techniques. Embedded computing system often involve the design of hardware as well as software. Design methodology for a combined hardware or software project. It's a block diagram of design methodology, combined hardware and software project. Hierarchical design flow. Embedded system must be designed across multiple level of abstraction. First one, system architecture. Second, hardware and software systems. Third one, hardware and software components. Next, concurrent engineering. Concurrent engineering attempts to take a broader approach and optimize the total flow. Reduced design time is an important goal for concurrent engineering. Concurrent engineering is a systematic approach to the integrated concurrent design of products and their related process including manufacture and support. This approach is intended to case the developers from the outset to consider all elements of the product life cycle from conception to disposal including quality, cost, schedule and user requirements. Large projects use many people from multiple disciplines. Work on several tasks at once to reduce design time. Feedback between tasks help improve quality, reduce number of later design problems. Thank you.